All right, it's 3 o'clock. Probably be a few more attendees that'll meander in. And I'd like to welcome all you guys to the ARC forum here in sunny Orlando. We'll be going to the swimming pool, afterward for a drink by the bar. Oh, wait a minute. I got the wrong meeting. All right, that's how it was supposed to be. All right, but we have some great speakers today. We have Brent Kedzierski. We have Dr. Matt Malata. And we also have Ian Willits from Aviva. And we're going to launch this presentation off myself. I'm going to give a brief introduction. We're going to present a little Mentimeter survey. So if you have a cell phone that has a cue card reader, it would be handy to use that because we're going to use this cue card, and I'm going to start that shortly. So this is the order of presentation. I'm going to start with an intro. We're going to then go to Brent from Shell, and then we're going to go to Matt from Reliance Refining in India, although he's actually speaking from Chicago. He's not speaking from India at whatever 2:30 in the morning. All right. All right, I'm going to bump that screen off and start sharing my screen. So I'm assuming you can all see this okay. And this session's about operator training systems, simulators for high consequence processes. That will include nuclear power plants and chemical plants and refineries. At the end of this session, when we go to the panel discussion, we're going to discuss this survey. And actually, Alan, if you could paste in that Mentimeter link into the chat. I can't quite get to it in my current view. That this will give instructions. All you have to do is go to menti.com and enter this 7-digit code at the top of the screen here. And you can take this very easy to take survey, or you can use a Q code reader and it'll just go immediately on your phone and you would be able to take this survey. All right. And basically there's only questions like for console and field operators. And let me go back up to that about which is the best type of training for console and field operators: classroom, on the job, 3D virtual reality, or unit specific high fidelity. And we just want to get your opinion on that. And I think it'll be a good lead into the panel discussion. We also encourage you to submit your questions into the Q&A widget on the bottom of the screen. Try to use that widget and not the chat function. Alan will be monitoring the chat, but you're more likely to get your question answered if you input that into the Q&A part of the screen. Great. So our speakers will be Brent Kedzierski. He's the head of the Shell Learning Strategy. And Dr. Matt Malata, he is the president of corporate business development from Reliance Refining. And we have a panelist, Ian Willits from Aviva, a vice president of process and simulation. These guys all know simulation very, very well. And we're going to be very interested to watch their presentation. So first of all, what should an operator actually know? Why do we need to train him? Well, operators in high consequence units, they need to be aware of the situation. They need to know who should take what action and when. They need to understand basic chemistry and physics. So a fundamental background, in physics and chemistry is really essential in order to be able to learn the rest of how things work. Because you're not going to be able to figure out how complicated process equipment like a reactor or a distillation column work unless you have some idea of, how vapors and liquids work. All right. They're going to need to know standard operating procedures. One of the hardest things for them to know, however, is abnormal situations. You could imagine that it was very hard for the Fukushima operators. You guys might want to mute as well while you're waiting. It's very hard for the Fukushima operators to suddenly deal with an abnormal situation for which they never trained. A wave came in, went over their electronic switchgear, the total station blackout, they had no power, the control room went dark eventually, and they didn't really have a standard operating procedure for that, all right? And that's a particularly interesting accident. And I think that all of us that work here in operative training simulators, we try to look at what those accidents are. Okay, I want to show you something right now. All right. For example, this is not a fake bookcase. All right. You know, we're talking about looking at what these accidents are, how they worked. That particular book from Union of Concerned Scientists goes minute by minute of how the operators dealt with the situation and how much stress those operators had. And believe me, they had an awful lot of stress and they worked very heroically. Unfortunately, at the Chai system, they lost 3 reactors and melted them down. In fact, that first reactor melted down within 5 hours after the tsunami wave hit that plant. All right. So they didn't have a lot of time to act. But nevertheless, training on abnormal situations and nuclear power plant operators, they do train on reactor meltdowns, and they can simulate the full neutronics of the reactors as part of their very sophisticated simulation systems. The other thing operators need to know is they need to know in great detail how the control and safety systems operate. And not just the steady state operation, but how do you start that unit? What are the permissives to start that pump or start that compressor? What is the sequence of events for little overlay displays and custom displays that they only use when they go to start up? And they may not start up again for another 3 years. And if they didn't happen to be on shift during that startup, they may not have actually got their fingers on those control buttons. So a simulator really helps them to learn the control system and how it works. And of course, operators need to know the field instrumentation. They need to know a lot about where their measurements are, how they're calibrated, which measurements are in service, and any idiosyncrasies of those measurements or pumps or valves or actuation equipment, because, you know, there's always trouble with valve stiction and issues with field equipment and how it works. They also need to know the state of maintenance and the current situation that exists in their plant. You know, sometimes the simulators are built for the plant as it was designed, and they didn't take into account that the reactor catalyst is degraded or that the tray efficiency of a distillation column is not quite up to its normal operation. So sometimes the simulation is under the ideal conditions, and sometimes the simulation, typically simulations are built to do the design conditions, and they're not modified to match the actual current situation in the plant. But, you know, and it's not just about safety, it's also about how to operate efficiently, how to make quantity of products, how to keep the product quality on spec. You know, those are the things that technically are secondary to safety, because safety is always the highest priority. But nevertheless, training simulators will empower operators to do all of these things. I'm just going to go through 3 quick accidents, you know, where training was a pretty big issue. All right. In the Navy destroyer, the SS John McCain collided with a frigate. All right. And new controls and poor operating supervision and training were responsible. Chernobyl was a huge accident where operators were experimenting with a turbine to keep the steam turbine running so that they would have electric power long enough to start the diesel generators to keep the coolant pumps running. They were trying to do this for safety reasons. Unfortunately, they missed a lot of things, and there was there was not that many people killed right there. Some firefighters, a dozen firefighters and things, but tremendous amount of damage is done in nuclear power plants because of the downstream radiation. Chernobyl, by far the most expensive accident that we know of. Fukushima was number 2. You know, accidents in refineries and chemical plants also are big, but not usually as expensive as nuclear accidents because of the downstream radiation problem. Texas City Raffinate is a very well-studied reactor, killing 15 people, operator errors, and poor management. In the case of the Navy destroyers, you know, 10 sailors died when operators had this new touchscreen bridge control system. In fact, the chief petty officer had a whole 1 hour of training, and he then was responsible for training all the people that are supposed to use this. Clearly, they just didn't know how to use this, and they were navigating in tight conditions. And you can see what happened to this. It happened to their ship. They crashed. All right. They didn't know how to use the system. This was absolutely an operator training, and really, who's responsible was the supervision that was responsible for setting up that training. The Chernobyl reactor is a very well known, very well studied reactor. You know, the whole sequence of events that occurred here are just amazing. had those operators trained on a training simulator, they would have been able to predict that they had the xenon poisoning effect. You know, nuclear reactors, when they trip, they can't really start up again for 9 hours due to the neutron absorption capabilities of xenon that accumulates in the fuel rods. And they were trying to start up and they forgot, geez, there's no reactivity. They kept pulling the rods out, pulling the rods out, pulling the rods out, and it wasn't working. And then all of a sudden the xenon started to decline. And that in combination with a positive void coefficient means that when they pulled those rods out, they had a very sudden massive heat release. It's not quite clear. This could have been a prompt critical situation, but it may actually just have been a steam explosion. All right. Generally, nuclear reactors don't blow up like nuclear bombs, but they can still get into a lot of trouble, as we've seen. You know, the raffinate reactor in Texas City was well known. The operators were going on one shift. They went into the night shift. They didn't realize that the bottom level in this distillation column filled up beyond the level transmitter. The level transmitter did not indicate that it was 100% level. And so the operators thought that the level was still down in the bottom of the column, but they actually filled the entire column all the way up with liquid. The liquid overflowed into the reflux drum, and on the right-hand side of your screen went to this flare system, overflowed the flare system with liquid, because it wasn't a flare system, it was a collection system. And eventually that liquid ignited, and then you had a pretty big bang. All right. So here are some different situations that clearly would have justified a simulation. And you probably could have asked a lot of these guys, the management of these people, the day before, what's the chances of having a very serious accident in your plant? Oh, well, it just wouldn't happen here. You know, our plant just, you know, is well trained. We have the right situations to handle these things in the training, but in fact, they didn't. So you definitely want to take a look back and make sure that you have adequate training of your operators, maybe even I know we had a guy from NIST that was talking about having a certified training program. You know, so if your program is proven to be safe, and in the nuclear industry, there is an ANSI standard 3.5, which specifies how training simulators are to be built. We don't see that in fossil refining or gas processing or chemicals or pulp and paper or some of the other places where you might find simulators. Clearly, pilots, surgeon, you see tremendous heavy equipment operators, you know, from Caterpillar Tractor and Kubota, all training people because of so many accidents with cranes and excavators, where they need to train with very sophisticated simulators. In any event, simulation-based training is the fastest, most effective way to train operators. The operators that get trained from accidents, they may actually realize, yeah, I did something wrong, but when they did something wrong in a simulator, it's much less consequential. In any event, I would encourage you to click this link in the chat box. You would also be able to see that there's a link that Alan should have put up there. If not, I'll put it up myself. And we'll review this survey at the end. And now, thank you for that. And I'd like to introduce Brent. I'm going to stop sharing. And Brent, you can share your screen at the bottom, launch PowerPoint, and start your slideshow. And unmute.
Okay, Rick, Brent here, and I'm working to share screen. It's taking a little bit of a delay for some reason. Let me just see.
Usually if you share screen, you'll have to pick one of your applications to make sure you find your PowerPoint. All right.
All right, I think here we go. Great. Thanks, Rick, and hello and welcome, everyone. My name is Brent Kedzierski, and I'm the head of Shell Learning Strategy and Innovation. I'm really happy to be here. And what I'm going to talk to you about is about really building on what Rick talked about safety, the importance of operator training, and where we think it's going. So what I want to do is talk about the future of human relative to operator training simulation. You see the crane, which is the bird of happiness and prosperity. That's what we think the future of human is with operator training simulators. And you can see one of our Shell operators here in the era of personas that we work on so much at Shell, which he's actually just completed his do-it-yourself business app. And so he's seeing his fruits of his own thoughts and efforts pay off. This slide is the standard shelf slide. It's just saying that I'm not going to say anything in this conversation that's going to change the price of oil, anything about the markets. It's not going to tell you to buy shelf stock or sell shelf stock or anything like that. This is really a presentation about what we think around people development and safety of our assets and our folks. The presentation in itself is going to really go around a few concepts that I want to get through to this group. And I want you to think about what Rick showed you of those three examples and what Dr. Matt will show you and talk to you about and what I show you. And think about it relevant to you, your experience, your operations. So the first point I'm going to say to you is everybody has experience with bad work tools, bad training, and bad managers. And we all have those stories. We can sit around the campfire and share those stories. The disasters drove physical and environmental reform throughout industry. And that reform has happened in the 1700s, it happened in the 1800s, and happened in the 1900s, and now it's happening now in the 21st century. They've all been different levels and types of reform, but it's all been relevant to worker conditions, managerial approaches, safety-related standards, and things like that. So we've evolved, and we continue to evolve. The physical environmental safety, like the Chernobyls of the world or the Texas cities, we should expect not to have those today. Unfortunately, we still do, but we should really be bearing down on a goal zero type of safety environment. In our next frontier is really more about this psychological safety of our workers. And I'm going to talk more about that in this pack. We're entering, and we've talked about industry 4.0, 5.0, but we're now in this thing of conceptual age that's really driven by abundance, automation, offshoring. And that's really driving higher level expectations. And the expectations are for things to be, whether it's work or personal, it's higher touch, higher concept type solutions. So we'll talk a little bit more about that. And then again, many of us have talked about Industry 4.0. I don't know how many of you know about Industry 5.0, but we'll talk about that. We're still struggling with 4.0, but 5.0 is on the horizon, and I want you to understand the impact of that in what we're doing. And the thing about Industry 5.0 is it delivers more adaptive and personalized experience for our workers, right, as our customers. And it really leverages X and O data, which is experience data and operational data together. And that's the things like Ian Willits, who's on the call, can talk about solutions where we integrate operational data with experiential data of simulations and different kinds of tools and things like that. This picture is close to my heart because it's a picture of my grandparents. This gentleman circled here is my great-grandfather. He worked at Allegheny Steel, and the young lady on the right-hand side of the screen, that's my grandmother. My entire family is from Pittsburgh. We all worked in industrial settings, whether that was steel mills or textile mills or chemical mills or anything like that. And what I would say is there's a name there at the bottom, Lewis Hine. And throughout the history of the 1700, 18, and 19, there's always been these social reformers that have documented working conditions through either etchings or photography and things like that. Lewis Hine was a gentleman that went to Allegheny Steel, where my grandfather worked, in 1907, and he documented, and he did the first industrial study of an industry. And he basically went into Allegheny Steel, he talked to the workers, he did statistics to find their nationality, their breakdown, what nationalities they came from, what their living conditions were like, what the working conditions were like, and he documented that through photography. And many times, people in government didn't believe his photography. They thought it was almost deep faked or something, and that's the kind of the situation. But he really struggled to support child labor laws and reform. And out of this Allegheny Steel study, they got concessions for the 10-hour workday and workers' compensation. So gentlemen like Lewis Hines were really important in advancing the worker cause. We all are on this call because we work in hazardous professions. That's nothing new, and they all produce issues to our well-being. This is another photograph by Lewis Hine. It was called The Breaker Boys. And it basically was one of the most instrumental photos in history to resolve child labor laws. The Breaker Boys worked in the coal mines, and they would sit on wooden planks, and while the coal chute shot coal down the chute, they would try to use their hands to pick out stones and rocks. Many of them lost all their fingers. They weren't allowed to wear gloves. They sat in there all day for 10, 15 hours, and they made like 10 or 15 cents a day. But photographers like Lewis Hine and Winslow Homer, who documented this other photograph, which was a photograph of the bell ringing. And the bell ringing was in New England in the textile mills, where they hired women and children to go into the mills and work. It was kind of showing the social reform he was trying to have. Now, when immigration came, these were considered great jobs. When an immigration changed, they found immigrants that would do that work cheaper. Now, this is something that I want to really share with you, and I really want to take you through a story. And imagine this is your persona. You're a young immigrant, Jewish, Italian immigrant female. You've come to America. You're somewhere around the age of 12 to 14 to 16 to 18 to 20. You get a job in this garment district of New York City at this what's supposed to be the state-of-the-art place to work. You get to make 15 cents a day, and you have a 10 to 12 plus hour work day. You work 6 days a week. It's a sunny Saturday, March 25th, 1911. And you start to hear screams, and you work on the 8th floor or the 9th floor, sorry, of this building. On the 8th floor, fire broke out because greasy oil on sewing machines fell into rags. Somebody lit a cigarette. It started a fire. You're on the 9th floor, and the wooden flame of the doors and the windows lapped in fire, which is a technique that the fire goes and it spreads very rapidly. You go to the exit doors, but they're all locked because management doesn't want you to take smoke breaks, doesn't want you to steal material from the shop, and there's only one exit door and it's jammed. You then go to the elevator, but you see a stack of women that have jumped into an empty elevator shaft to try to grab the cable to climb down. And you see at the bottom, 25 of these young women have crashed down to the bottom, and they're crushed by the elevator, and they make the elevator inoperable. Then you start to see pairs of women holding hands. They're jumping out of the windows hand in hand from the 9th floor down into the street with firefighters holding nets. And the nets break because the force of 11,000 pounds of a person falling from the 9th floor, the nets don't hold them. The fire ladders only go up to the 6th floor. So at the end of the day, you walk out of the building, you're one of the only ones that do. You've got over 70 of your colleagues that have fallen to their death. You've got 26 that have fallen down the elevator shaft and were crushed. And you've got the remainder of them that were suffocated or burned beyond recognition in the fire. Not a pretty story, but this was one of the biggest incidents of safety and lack of conditions. The after-action review that was done on this, everything that could go wrong by today's standards went wrong, whether it's sprinkler systems, fire extinguishers with water buckets. Most of the things we have today in safety-related protocols and procedures came out of this event 100 years before 9/11. that's when that happened. 36 laws and statutes came about by this incident, and it initiated the formation of the American Society for Safety Engineers, which is now it's the oldest society that protects workers in the United States today. I mentioned this as one story. There's lots of other, the Great Train Wreck of 1918, etc., all helped us get to where we think about training, where we think about safety and the human person in that space. But this was one day, the same year that the Triangle Factory took place. In 1911, there was an average of 136 Americans died each day in workplace-related safety incidents or training-based incidents. So I just tell you that story because, again, as I say here, grueling times, turbulent times, they offer great hope, unfortunately. And fortunately. So the point I'm trying to make here is that physical safety is something that we've really worked towards and we should expect. Now we're moving into the 21st century into this more psychological safety, and that's where it intersects with training much more. Especially OTS. Another famous etching that was done in the 1800s, early 1900s. This is called "The Miner Emerges." It's about the miners that were getting better worker conditions. And what we talk about psychological safety, and some of you may heard this term, but there's 4 elements that we look at. It's the inclusion safety, which is, do you feel included in your workplace? Do you feel able to give commentary, able to give input? Then do you feel safe to actually learn? So when we talk about OTS, is it okay to experiment and learn? Do you have a safety in terms of your contributions? Do you feel it's safe to contribute? And the highest level is, do you feel that you can challenge? And those are the things that there's much more into all those, but those are things that really are important. And Alfred E. Perlman, who was one of the great railroad executives of the 19th century, he had actually made a quote somewhere in probably 1930. And he said, learning is what adults will do for a living in the 21st century. So I'll give you a quick summary on psychological safety. So the whole psychological safety, and there's a lot of work that's been done on this, and there's 40 years of research today, basically long work hours, absence of job control, economic insecurity like with COVID and things like that. All these things, and the person always having to be on, to be sharp. That drives the workplace stress, whether you're an operator, air traffic controller, especially those people that are working in high pressure professions. And I know even like a lot of the medical professions now, there's so much stress out there because they're always having to be on right now with this COVID. It's driving unhealthy behaviors, things like drinking, smoking, drug abuse, overeating, lack of exercise, and that's impacting workplace health. So this is why we need to improve the psychological safety, OTS, and giving people confidence in their ability to contribute to the good design of their work and being confident in their abilities to execute their work. That's why the investment in training is so important, more important than ever before, because it's not only environmental issues that we've got to be concerned with now, or physical asset issues, but it's also the emotional stability and sustainability of our workforces over long periods of time. I think this is the last few years are some of the first years that the lifespan of Americans is actually going down. Work-related stress is the #1 cause of death in the United States right now. So that just gives you a background. Those were 6 slides that I wanted to share with you to say, okay, what's the context of what I'm going to talk about right now? So now we say this Industry 5.0 that's on the horizon. And if Industry 5.0 is all about the intersection of humans and machines. Okay, so I'm going to talk a little bit about the backdrop of this. So we know that, in the 1750s, and actually the first actual factory in the United States was about 1780 or 90, I can't remember, but it was up in New England. And the first chemical industry actually was the slaughter of pigs for the chemicals and substances that pigs produced, and for soap and things like that. But anyways, we had mechanical manufacturing with the water and the steam, and it turned things. And then we had the mass production that was enabled by making the 24-hour work data plant with the plug, the assembly line, the movement through electricity. Then with the computer age, we got computing digital storage, the ability to copy, which created kind of the information age, right? Because we could have so much information on storage. Then we came with Industry 4.0 only in 2011. With smart production, that's the IoT, the Internet of Things, the cyber physical connection of tags and sensors and drones and all the information we could do. But what we failed in a lot of this is tying all this great digital stuff to what the humans really care about. And that's why the mass personalization and the connecting the human to all this great smart production stuff is now the Industry 5.0, and it's basically more on not just the connection of data between the Internet of Things, but how does that relate to the human experience? So look at what I've got on the left here is this mass movement, mass production, mass information, mass connectivity. Now we're in this age of mass personalization. So it's marrying the human element, right? The human factors, the elements of that with the automation aspects. And what that does is I show you here this Industry 4 capabilities with the conceptual age expectations, where you've got the shell worker impatient, overwhelmed, distracted, and they want solutions that are untethered, on demand, collaborative. They want to be empowered so they can make their own choices, decisions, and go into something. Well, that's the high touch, high concept solution. And there's a lot of talk about this right now in industry. There's also low tech, high human, all these other variables, and they all have a place. But what we're talking about now with our OTS, how do we make our operator training environments, not just systems, but environments, higher touch, higher concept, so that we can make them more mobile, more on demand, more collaborative, more about all these things. So these are the kind of solutions that our operators want now, not a static simulation from an OTS, but they want to have a more integrated, personalized experience. Over the Christmas holiday, I was looking at kind of cool gadgets because I like gadgets. I'm a gadget guy. And then I was looking at this thing, and everything that was going, like if you Google, and I Googled this source here, the 15 amazing new gadgets for 2021. They've got a toothbrush now that you see where I've circled it in red. It's personalized to you. It'll give you data on, did you use it? How many times did you use it? All these. I'm waiting until the dental floss does that. But now they got a smart mirror, so it tracks your health. So everything's not what it used to be. Light for my steps. And it wasn't just a light, it was a thermometer, and it did about 12 different things. It's like the Swiss Army knife. Same thing with this mask now you see. It's a high concept, so it's customized, and it tracks data on the person. So again, everybody is expecting these higher touch, so they're more personalized for me, and they're higher concept. They do more things for me. And so this is where we're going in terms of these types of solutions. We're seeing it in our personal lives, and now we're starting to want to see it in our work lives. This is just a slide that I'll tell you the two concepts of the slide. If you look on the right side, this is kind of the shell environment. So a cyber physically connected environment with our assets, the tags, the drones, the robotics, all of these things that are automated. Then you've got the worker environment, and they're wearing their wearables. They've got their iPad. Everything's supposed to be connected into the cloud. And then it's helping them to do output or outcomes related things. So support, guidance, coaching, data collection, analysis, synthesis, decision-making, problem-solving, task support for execution, procedures, digital procedures, escalation, documentation, all those things. And that's what we're we're seeing. Now, one of the things I'm highlighting here, because I think it's the best Industry 5.0 solution that we've got in Shell so far in the operational space, is this Shell do-it-yourself, where it's called citizen development. So the operators themselves can build their own apps, they can do their own solutions. And that's the same thing with OTS. I want OTS that the operator can come up and build their own simulations, build their own training exercises, be able to share those with their colleagues, be able to gamify and test those with their colleagues. And this is a deeper dive into this. So we're using these power apps that the people closest to the issues, the closest to the business, so we don't need a McKinsey, we don't need an Accenture. These people can enable themselves to curate their own solutions themselves. And then there's a whole scale. If it takes fire and goes viral, then we'll get it professionally done and invested in. And we're doing this stuff now in days, not months. It's not going through big procurement channels and all kinds of things. It's the operator that's building the solution. And that's what we've always wanted. You know, think about 100 years ago, the miner. If the miner could build himself or herself a better shovel, that's what we would have wanted, that fit their hands better, that helped them do their work better. They were the best to fix and figure out their shovel. My grandfather, who was a machinist, he was always making these tools that were custom for him and helped him because he could do it. Why can't we do that in the 21st century now with our workforce? Let them build their own solutions and enable them to create their own environments that are personalized solutions for them. So these citizen developers are the ones that we want to solve the problems quickly and safely. And that's empowering them to lead and manage their own environment. Another thing that we're doing, and I won't spend much time on this, but this is Ready Operator 1. And Ready Operator 1 is an environment-based experience where our operators get a chance to improve their skills based on real-time daily routines, real issues that are happening to them or that they can influence and shape. So they can say, I experienced this, we should probably document this, and other people should be aware. It's a gamified journey, and we'll talk a little bit more about why gamification is so important to today's mind. And basically, it's helping them identify what good looks like, what bad looks like, and develop the skills to know the difference between. And this is our human performance and safety enabler system. So why is this all relevant to OTS? Why, you know, when you listen to Rick and Matt and Ian Willits, the bottom line, and this is where I say the bottom line becomes, you want to build experiences for the modern worker, and an experience that has these characteristics is much more effective. It will transfer to their brain, it will stick in their memory, and they will value it more than solutions that quite honestly didn't have these elements. And the basic elements that we want is when somebody's putting forth effort, and you see my little 3 red bits over effort, performance, reward. The big idea in a human performance model is people look at tasks and everything's personalized. They look at it from their point of view, their reference point. They look at that task from a subjective and personalized view. So you might give everybody the same task, but everybody's going to have their own internal, external motivation, and they'll say, do I accept the effort that that task is going to take me to do? Do I believe I can successfully perform that task? And do I value the reward for having accomplished that task? Do I think it was worth it? So that's what every human does when they look at work. And if they don't do those things, they typically fail in flawless execution. So we want to have a mission. Do they deeply connect with the cause, the purpose? Is it problem-centric? Do they feel value in what they're doing? And look at the simulations that we want to build for people, right? So they want to know that aha, that intellectual, emotional stimulation. The context. So are we giving them the context of solving the problem, making the decisions, and we're giving them that context so they can actually analyze, synthesize, evaluate in a way that they learn by doing it. Okay, they know the attributes of the decision and the decision cycle they have to go to make it work. And do they see the value in addressing that challenge? Okay, what's the challenge going to do for me? And then the choice. Do we give them choices that are diverse enough that will help them to really make it stick and really make them think about it in memorable ways that they'll retain? And then do we also put consequence in front of them and that gives them memory markers? Say, I turned the button this way when I should have turned it that way, and that's why it's going to remember, why I'm going to stick with it. And then the last thing is there's a term out there, and I don't want to get termy with you, but this neuro agility. It's a fancy way to say learning better and faster than we have before. It's being much smarter about how quickly we learn new things, how quickly we can let go of old ideas, and how do we put solutions in front of people that help them think better, faster. And that helps with the brain performance. So those are the areas that I wanted to share with you. I'm going to go ahead and turn it back over to Rick, who I think will introduce Matt.
Wow, thanks enormously, Brent. These were things that were completely missing from my presentation. This is why we have multiple speakers, to get all of those personal points of view. I mean, the human element of training and creating a training environment is just amazing. We're getting a few questions in here. Please give us some more. If you have yet to take our survey, I've just posted in the chat the Mentimeter link. It's a very quick survey. We're going to review these right after Matt's presentation. So without further ado, Matt, can you please share your screen, and we're very interested to see your presentation.
Can you see my screen?
Yes, perfect.
Okay.
Great, keep going.
Can you hear me?
No problem.
So thank you, Rick, and panelists and attendees. My name is Matt Maladi. It's my privilege and honor to participate in this forum. And thanks to ARC Advisory Group for giving me this opportunity. Over the next 25 minutes, I plan to talk about the developments in immersive training simulator for manufacturing. And I did speak about it initially 2 years ago. Since then, we have done some more work, and it has come out quite well. And I'll share who all have gotten to see it, which we are very proud of. So in this presentation, the need arose because of urgent corporate need and a challenge presented by our chairman and managing director to my team to enhance quality and safety of operations, to improve employee retention. And we do have a serious problem in that part of the world. We train a lot of people, and they get hired away in Middle East and other parts of Asia. And therefore, training has become very difficult and needed some overhauling. So I'll get into details of that. So speed up of training was important to get people fully assured and competent. And also with the new crop of millennials showing up in the job market, retention has become seriously an issue for younger people's retention because they would like to go to startups and computer-oriented activities as opposed to operating a unit or managing a site that deals with hydrocarbons. So with that in mind, my outline of the presentation. Okay. Has four bullets. I'll explain the project motivation, what it involved, and then what immersive training simulator did to solve the limitations of the system and why. And then we'll talk about how we progressed implementation of the pilot and who all got exposed to it. So coming back to primary motivation uh, is to create and sustain a competent frontline workers and supervisors with technical authority to make decisions. The competency assurance system, which is quite well discussed in the industry and in presentations, in forums, was developed in Reliance from grassroots, meant to achieve this goal. However, our attrition and the speed that we needed to train and develop competencies and assure exposed system limitations. In fact, we got tremendous help from Shell in designing the system. And as we go forward, I'll talk about how Aviva was involved with our new solution. Hence, we focused on something called world-class assessment center using immersive training simulator. I'm going to go into details and expose you to details under the hood, the components that went into Aviva's XR platform, and how it was interfaced or integrated with our high fidelity OTS. I'll talk about design architecture, scenario design, and some elements of what we incorporated in how to simulate the real world. That would be followed by the project work streams involved in developing such a system. We built a pilot and demonstrated it to a number of people. To date, we exceeded about 600 demonstrations. A notable one is with the president and CEO of Saudi Aramco and the chairman and managing director of Reliance. So we got tremendous accolades at the end. So now moving to Reliance, a lot of people know about Reliance, but Reliance is now much more diversified than what you used to know. On one hand, it has downstream and hydrocarbon related activities, which are very well known and world-class facilities have been built. On the other hand, we have upstream hydrocarbon activity in India and in US. We also have expanded our diversification into telecom and retail. And the most recent news you must be hearing and reading about is the telecom side, where every large corporation from US has invested in Reliance, and its valuation has almost approached ExxonMobil now. But coming back to hydrocarbon manufacturing, it's our core still, and it accounts for 80% of our revenues. We consistently achieve top quartile performance in key operations as measured by Solomon surveys. And we have the world scale, and it's highly integrated and efficient. After most recent third expansion of the location to include olefins and aromatics, we have rededicated our activities to look back at what we do today and how we can improve our productivity and HSC compliance, reliability, and quality. And a lot of this we have achieved quite well because of our continuous focus on people and competences and skills, and also adopting the best practices that are available wherever they are, and weaving those with our asset designs so that we get world scale operations at the lowest cost. So to sustain this program, we believe competency assurance system is a key. For us. And it is required because we want to avoid catastrophic safety events of the type Rick described. And while there are many normal reasons, we always find our accidents and emergencies are due to lack of training or lack of competence assurance. And hence we started focusing heavily on competency assurance system to avoid these events. And this being a crown jewel of Reliance, the management is extremely paranoid about that. So CAS is a must to avoid and minimize these issues. So I want to just quickly give you an overview of CAS system. It's very well known to everyone, but for those of you who want some orientation, what is a competence? The ability to perform work activities to standards required in employment. What is competence assurance? It is to assess an individual's competence against established proficiency and standard. Now, which competencies did we cover? We covered uh, all the four levels: leadership management to industry, functional and business, technical HSC, and personal effectiveness. To do this, we built a framework. And this framework describes all the competencies and skill levels in a common language, for which we needed to develop competency catalogs and job competency profiles. So say, for example, we have 10,000 people, and in the past, we used to talk about their job descriptions. Today, we talk about their job competency profiles, and it's automatically extracted from catalogs. And this is where we collaborated with Shell's approaches and benefited from it. Now, competency assurance system has two elements. One is competence development, which is the traditional training and learning is what we used to call it. And then a subset of it, which is competence assurance, mainly focused on HSC critical tasks. Now, competency development today is a targeted learning intervention for each employee based on their gaps, skill levels, through either classroom or e-learning or workshops, workplace OJT, mentoring, simulations, and certifications. That's a very well-known set of things that are used today. And that is what an employee is exposed to. First comes in, gets his profile mapped, then he goes through gaps. He fills his gaps through these various means which are automatically administered to him. Then comes assurance. Assurance and mentoring traditionally happened in the field, and it is mainly for licensing the employee to operate, the frontline operators, the maintenance technicians or QA/QC, with focus on mainly HSC critical tasks, which are either routine or non-routine or emergency oriented. So there are three types of tasks we see in a refinery. They are routine normal, they are non-routine normal, such as startup or shutdown is a non-routine normal. And then there are non-routine abnormal, which you never expect, but a group of things come together to cause the emergency, and for which you usually are unprepared. But if there are frequently occurring emergencies, you do develop situational awareness to handle them. And all these decisions made during operations and routine, non-routine are overseen by technical supervision. So the technical authorities that oversee these also are assured as part of this system. Now the process has three steps. The first step is, of course, mapping the employees' job competency profiles. I'm not going to go through all the boxes, but as you can see, there are three vertical columns, and first two fall under competency development. One is the left side one is to take the employee master data and map their profiles. The middle path, which says inputs, all the details of competency system allow this employee to self-assess, followed by the supervisor, and then the gaps emerge. Then they go through learning interventions to fill those gaps. And the extreme right side one is the assurance step. where there is a very rigorous way of assuring an employee after they go through the learning interventions and also OJT, then at the end of the day, they are scheduled for assurance in the field one by one. And this is where we went the extra mile. We learned from Shell that they do indeed go every equipment, every compressor, every pump, and they go through it systematically using the process that we have modified somewhat, but looks very similar to what we have, which is plan, assess, record, and feedback. We follow these steps where we test the operator for online knowledge, followed by test, uh, followed by personal interview, and only for each of the competencies the employee passes, then we take him to the next group of competencies. And all of them have to be cleared before we pronounce the operator to be ready and licensed to operate. So a typical pyramid for competency has those 5 levels on the left side. Personal effectiveness to spans up to management and leadership competencies. For our CAS system, we borrowed mainly functional and technical. And to the right is a typical table which shows about 23 competences for various positions, the field executive to panel officer to shift engineer up to plant manager. And the numbers in on the right side table have to do with the proficiency level that are expected for a given competence that is listed among these 23. Now, this was duplicated for 8 different areas, starting with chemical engineering, process, HSEF, maintenance, mechanical, electrical, instrument, etc., etc. So it was a very big undertaking, and it's highly automated so that people know what they're expected to learn and what they would be assured on and at what proficiency level. Now, we took that to the next level. We rolled it out to all our manufacturing locations, about 10,000 employees, and very quickly found that while in a Shell or a Exxon Mobil, these systems work because you retain employees for longer duration. In fact, many of the operators retire on their jobs, and some even move up the career ladders in these organizations. Back in Reliance, majority of the employees are engineers and diploma holders. There is no high school graduate joining as operator. So these guys, they need a lot of excitement. They need that psychological challenge which Brent talked about. They need tools and learning and doing things differently. So very frequently we lose a lot of these just out of because of the Middle East and the expansion in Middle East and Asia and Indian workers being graduate educated, and for them.
Hey, Matt, we're losing some of your sound. Can you move closer to the microphone?
Can you hear me now? Hello?
Yes, much better.
Okay. Sorry, I didn't realize. So we rolled it across manufacturing. We found a lot of limitations due to attrition, and so we found that we needed faster way of knowledge transfer and assurance. And the typical system took us 2 to 3 years to take an individual to a level of assurance for those 23 competencies which I talked about. It also involves live equipment practices and plants and for OJT purposes, which involves hazards and hydrocarbons. And very frequently, this equipment is not available for OJT for assurance. So these limitations caused us to look elsewhere to speed up the system and improve the quality of what we are trying to do. So we came up with the help of Aviva's XR platform, a world-class assessment center idea concept, which we developed further. And so I'm going to give you details of that. So what is immersive training simulator? It's basically a amalgamation of virtual reality and augmented reality platform, which can be driven by a high fidelity operator training simulator to drive the ITS and also replicate actual plant operations in 3D. What it does is it significantly enhances breadth and depth of training and assurance, and also eliminates live plant hazards and plant unavailability issues. Because it's available all the time, one can practice in any mode, whether it is exploratory mode or assurance mode, in safe environment, and perform critical tasks repeatedly so that there is a repeatability in decision making and minimization of errors that an operator faces when performing these difficult tasks. And it also complements and structures actual OJT. Today, OJT is done in different ways in different companies. A mentor is assigned. He takes this youngster with him. If that day he happens to start up a new compressor, he may expose him to that. If it doesn't happen, then he has to really plan systematically, as I've shown in the process flow. And this usually takes a lot of time. Whereas a simulator allows the trainee to access what he needs to access on his own and drive his own learning in various modes, either learning mode or in assurance mode. And it also scales across the manufacturing plant and sites where there are repeat equipment or repeat plants, which uh, um, have to be mastered by different people. Now, what it does is it puts burden on OTS. The OTS has to be extremely accurate to simulate the unit and the controls as much as possible. It also extends its use to frontline operator and engineers beyond what we do today. We use it by panel officers or the board operator during commissioning. After that, it is only a continuing education. Whereas when we extend OTS to include scenarios and effects and what ifs, uh, then it can be utilized by more than just the board operator. It can be used by the operators and engineers in their own surroundings at their own pace. Uh, and the OTS, when integrated with the ITS 3D platform, it becomes the immersive training simulator. Now, within this ITS OTS linkage, we have built in a number of augmented reality capable features, which allows the operation of equipment or knowledge transfer or visualization for these frontline operators and tech service and reliability engineers. It also provides a platform where a subject matter expert, through a head mounted device, can train or guide an operator in the field if we could work specific scenarios and routine, non-routine activities into the system. So now moving on to what's inside this immersive training simulator. I have shown this earlier, but it hasn't changed because it's a conceptual platform. Aviva's extended reality VR AR platform is a center. And for a plant to be transformed into a AR VR system, what I have listed on the left side is a must. Basically, you need a 3D CAD and go through the process, which I'll elaborate a little bit more. The photogrammetry, laser scans, or 2D info, all that has to flow in. And on the top, you have manufacturing external data source, which is you have the right interfaces to put exactly the type of information you want or access the type of information you want for the type of user. And for example, for operator, the main thing you want is the OTS ITS interface with operating and lab data QA/QC data flowing in. For others, they may have equipment information that has to flow in. So the entire platform is flexible and designed with interoperable interfaces so that they can be deployed for different user. A single platform can be deployed for different end user. So the layout typically may look like this. This is Aviva's rendition of how it may look. The 4 guys standing in front of screens are field operators. The 4 guys next to them are the panel officers. And the guy in the green shirt is the instructor. So you can run the whole show in learning mode or test mode. In test mode, usually instructor gets involved. We have taken it to the next level of even computerizing the instructor role somewhat to let them run through computer instruction rather than instructor mode. Now, what's most important here is that we have OTS operator training simulators for about 38 units. We have total 93 units. For 38 units, we have developed it. And as we developed it, the detail and the sophistication has improved on OTS. So at this point, our main goal is to use these OTSs to tie to a ITS platform and be able to simulate any unit or any plant as we desire. And the OTS inputs and the scenarios come from CAS, the lab management, information management system, and people data. And for ITS, most important is the 3D model and the engineering assets readily available so that you can build on those. And now OTS drives the ITS, and the interface has to be interoperable interface, so that if we change anything in the future, or if OTS is changed or configuration is changed, the unit operation is changed, or the unit itself is changed, we need that flexibility not to go back to the vendor and be a hostage. We just wanted to modularize it and keep the architecture open to enable rapid implementation of any changes. Now, there are 4 types of users I have listed here. Can everyone see it? Hello?
Yes, we see it, Matt. Probably have to pick it up a little so
Okay.
we can get to the panel session, but great job.
Okay. So we have 4 types of users. One is the panel officers, engineers. Moving down, it can be used for maintenance, mainly using augmented reality, looking at assembly, disassembly, inspection, maintenance of units. Or as I mentioned, moving to the right side on the top, competency assurance, where you can look at operating in normal circumstances or abnormal. And the last one is assurance aspect of it, where the instructor or the computer poses routine, non-routine scenarios, and the employee goes through that to complete the activities with minimum errors. The types of users are listed here, which you can relate, so I'm going to skip this. There are 3 most important requirements to build an ITS. You need a 3D model. You need an OTS, and that simulates the DCS system. And you need a as-built 3D model and photorealistic graphics overlay. These 3 are the key items required, whether it is a greenfield or brownfield, to build the ITS system. So now I'll quickly go over the scenarios. This is a summary of scenarios. They can, for competency assurance, there are 3 types: routine, non-routine, abnormal, and you have to take each of those in various areas like operation, maintenance, tech service, and organize them. And routine are SOPs, SMPs. Non-routine, of course, are like startup shutdown, and non-routine abnormal Usually there is no SOP. It's what it is. And if you faced it before, you know how to react to it. Then competency development ranges from unit to plant to site. And so I've listed a lot of details of what all people get exposed to with generic simulators and training. Now, this is a heart of how to use it. Basically, the entire system is designed into modes of utilization and training levels. The modes of utilization can start with exploratory, go up to task practice and assessment assurance, going vertically down. Going sideways, training level 1, 2, 3, 4 depends on familiarization to actually handling emergency response. Now, these 4 levels of training can be driven by computer or instructor led. So that is a matrix that defines the way we're going to use it. And the next slide just talks about what is instructor led and computer orchestrated, and you're familiar with it. So I'll go to the next slide. There are 9 work streams to build such a system. These are all Aviva oriented work streams. And it involves design and scope of work where we get involved and design it. System development configuration, Aviva does it, and hardware specification also they do it. So it's quite an extensive program where we have to develop storyboards and come up with these 3 types of systems that we have to follow: routine, non-routine, and emergency. Now at Jamnagar alone, we have identified several, up to 20, and then we have added a few petrochemical units for which we have all the 3 prerequisites. So the idea is to build them one by one. And once we built it and the pilot was ready, it was moved to a number of operators and engineers. And finally, it was showcased to a number of senior executives. And the most important one was the Saudi Aramco Reliance activity that's ongoing right now. So it was showcased to the CEO and CMD of Saudi Aramco when he visited us as part of the due diligence to invest in Reliance. So those are the youngsters that are showing. They're all with the system for less than 6 months. They were able to pick up the scenarios, utilize it, and explain each scenario and the actions. And that itself speaks about ITS, how fast people can learn with visual immersive training simulator. And this is the last slide where you see the CEO of Saudi Aramco and Reliance listening to these youngsters after they made the presentation. The best part was the Aramco CEO asked these 4 kids to give him his resumes so that he can hire them away from Reliance. And so that concludes my presentation.
So Matt, that is just fascinating. You train all of these people and and then let Saudi Aramco take them for their refineries.
Yes.
So the number of people you have to train is enormous. So that's fantastic. So great presentation. What I want to do right now, quickly, we have some questions coming in. We only have a few minutes. We can run a little bit over, by the way. And I'd like to just share my, I want to just share my screen here to show the results of our survey. All right. And that will. Oh.
Yeah, we lost you, Rick.
You lost me for a moment here, right? Let me stop sharing and get to the right place. All right. What I wanted was this one. All right. First of all, I'm going to present, and I'm going to share that screen. All right. You can see now the results of this survey, right? Yes?
Yes.
So very interesting results. You know, in terms of classroom or web-based training, most of the respondents seem to think that the console operators kind of needed that. So field operators, well, middle of the road. In terms of on-the-job training, you know, as the console operators, yeah, they need on-the-job training, but the field operators definitely needed it. I guess it's not surprising. This one also is not so surprising. In terms of 3D virtual reality technology, this is really the field conditions or the three-dimensional geometry of the plant. And so clearly the field operator has this very high, almost everybody agreed the field operator needs this. But actually the highest single score was unanimous, was that the console operator needed unit-specific high-fidelity simulation. You know, there are some people that would argue, well, you just need a generic simulator. You don't need a unit-specific simulator. You just need to learn about fired heaters or distillation columns or heat exchangers. But to really understand how to run your plant, whether it's Fukushima or the Reliance cat cracker or whatever, you need to know your real plant. So in any event, and also, but even, you know, so console operators particularly needed that, and the field operators also. So in any event, I thought that was kind of a very interesting, interesting result. Does that, Matt, do you agree that that seems to be a reasonable situation? I mean,
100%. We are not satisfied with what we have, but what, as I said in my presentation, OTS, ITS, both are needed for different purposes, for different end users. High fidelity OTS is a must for console operators. It is not used as much by field executives or engineers, but with proper design, with what ifs and scenarios, even engineers and field operators can benefit from it. Now,
oh, next question. Bruce Marvin asked, have you linked the training scenarios with digital twins? You know, can you discuss that? What do you, first for you, Matt.
Yeah, the question about digital twins is equipment, right?
I would assume so. Digital twins means different things to different people,
Right.
but
So in our case, I call OTS a digital twin for the controls of the complex, and they are segmented by plants and sites and equipment. So the fact that we have linked it with the OTS itself, for me, is yes, it is linked to digital twin.
Ian, do you have any comments on the training simulators, and how do you view this as a digital twin, the linkage? You know, would you call an OTS a digital twin?
Yeah, sure. So yeah, I think the point that you made, Rick, is that, you know, the digital twin means different things to different people. Yeah, when I think about a digital twin, when I think about a dynamic simulation such as an OTS, I think of it as a behavioral digital twin. So it's not just a data representation of an asset, but it actually, you know, gives you insight and knowledge that you can sort of understand the behavior of the process. So if you have that sort of cause and effect relationship from this behavioral digital twin, you can absolutely tie it into the training scenarios. So they can actually, you know, learn how to start up or shut down a plant by using the behavioral digital twin as a training scenario.
So this is actually one of my questions, and it's a question to Brent. All right. So if you unmute, you could be able to answer it. All right. You talked about citizen development. All right. And it almost implied that your operators could put together their own training program for themselves. And yet, when we saw Matt's presentation, he had a very elaborate certification of these operators to prove that they have competence. How can you assure at Shell? Clearly, he learned these things, some of these things from Shell. How can you assure that the operators have developed their own self-paced program and have competence? Surely there must be some competence testing of some form.
Well, there's standard competencies that we have, and they have to go too. I mean, there's going to be stages that we go through on this. So the first thing is, like, for example, let's take a learning from an incident. You know, who's best to replicate and design and build that simulation than somebody's that experienced it or has seen it? If you think about training, the old training model was you have a subject matter expert, and they talk to a training person, and the training person would take what's in that subject matter expert's head and format it into training. What we're trying to do now is basically eliminate that training person to a large degree and have a platform that allows the operator themselves to work with these platform systems that channel and funnel them. So for example, one of these systems might start asking an operator questions, and based on the operator's response to the questions, it would format the instruction accordingly to the right type of solution and all those things. This is something the military did 30 years ago with these kind of SME-based learning systems. So it's just something we've got to get more and more, and that's one of the things I hope to work with Aviva on more and more, is these platforms that can eliminate and get the hands of the operators straight into the training development. It's basically community development of training. That's the people that should be doing it.
So actually, that's interesting. This kind of brings up another question that should go to Ian. What recent digital technology innovations can supplement the value of an OTS delivered on a high consequence unit?
Yeah, so I just want to sort of, but before I answer that question, which I'm more than happy to do, just to support what Brent is saying. I mean, Shell, the work that Brent talked about, that the use of the Power Apps from Microsoft, and the building of the ability to capture that knowledge and put it in an application and then serve that up to people across the enterprise. That is a new development, and I think it's gonna from my conversations with Brent, I think it may change the landscape of the learning exercise. That doesn't take away from the work that Matt is doing, because we're also working with Shell, delivering traditional custom OTS simulators. You've got to look at the entire competency framework and the type of knowledge that has to be delivered. Some of it can be delivered in the classroom, some of it with e-learning, some of it on a generic simulator, some of it on a custom simulator, and some of it using Power Apps. So there's a number of solutions that can be applied. So back to sort of more recent. So I think the Power Apps type application that Microsoft are bringing through the cloud, I think is very exciting. Some of the other stuff we're doing at Aviva is we are integrating our operator training simulators with a learning management system. So you can build into the learning management system the competency set that has to be trained as part of a classroom or a lesson. And then, the learning management system will guide the trainee through that series of exercises or lessons. It will record who took the training, what score did they get, where were they strong, where were they weak. And we can also blend that with, we've also integrated some AI-infused micro-learning that can build upon that learning profile and identify the strengths and weaknesses and fill in those weaknesses in an ongoing sort of delivered through the app type application, where you can get quizzed and reminded that you went through training a month ago, and you were, here's some refreshers that are appropriate to your learning profile. So there's some really exciting developments coming in this field.
So Matt, you have quite a large number of process units within Reliance. You have refineries, you have chemical plants, you have a lot of integrated petrochemicals. Enormous. What are the characteristics, would you say, that would qualify these high consequence units to be suitable candidates for either an OTS or an ITS system?
We have, yes, you're right. We have about 93 units combined in 5 different plants. And we looked at it and concluded that our first focus would be on the most dynamic units, the ones which are fixed bed reactors, where things are fixed and they are cleaning up products and they don't vary their operation as much, as opposed to an FCC unit where the dynamics are dependent on 7 different variables, whether it is feedstock or coke burning or air temperature. So our prioritization always focused on the most dynamic ones, where within seconds the product comes out. It doesn't take an hour to come out. So our priority is on based on the dynamics of the unit. But we have not ignored the fixed beds or the processes where we need to clean up the products for quality. That is another requirement. We need to keep our eye on the quality, and what happens upstream affects the product quality.
So I got another question for Brent. Actually, before I give a question, I just wanted to say that Brent's presentation reminded me that my grandfather came to the US as a coal miner from Glasgow, Scotland. At the age of 14, he jumped on a boat and somehow got to the US, and that's how I got to be here. And, I was wondering if in that photograph of your grandfather, that my grandfather might have been in it, or nearby, because it looked about the right age group and about the right clothing style as well. But in any event, fascinating. But Brent, now you emphasize the human behavior that are built into your training. So, Shell is a very sophisticated technical company. We have all of these super duper, high fidelity simulators and mathematical models and complex technology. Yet you also took the extra time to try to emphasize the psychological stress. How did that get itself worked into the Shell? And clearly it seems like it's a very important part of the Shell training program.
Yeah. So COVID was a good accelerator to this. If you look at COVID, when people don't feel psychologically safe, they don't perform as well. They're not as alert. They're not as situationally aware. When they're distracted by worrying about what's going on at home or is their job secure, all those types of things are things that we're now learning in the way the brain works. I mean, we've learned more about neuroscience for learning in the last 5 years than we knew about in the last 500. So, for example, Ian and Aviva built us 20 operational mastery modules that were behavioral based. So they were based on what's a technique called behavior modeling. So it's basically showing someone the right way to do things and the value in doing it right, as opposed to the hazard in doing it wrong. So every person has to go up to an intellectual chain in order for that trigger in their brain to take place to say, it's worth me doing it right. And they have to go from a place to just listening to valuing to modeling. And that's the kind of thing we try to do in our training program, because I know I have to take people through those 6 levels of intellect before they'll actually have a behavior change mindset.
Wow. Yeah, that's very comprehensive. That's all I can say, to look at it in that level. One more question came in for Ian. In addition to the better quality safety and learning how to operate all of the equipment, what other benefits are there for an OTS system? Is it purely for field and console operators? Does it extend anywhere else? Do engineers or maintenance people use this? What are some of the other things you can do with some of these operator training technologies?
Yeah, sure. Yeah, I mean, I think this sort of ties back to the earlier question about the digital twin, and if you characterize it as a behavioral digital twin, how can you use that? So we've a very common use of a training simulator is during the a greenfield project as they're going into plant commissioning is for controls checkout prior to live commissioning. So you can take this behavioral digital twin of a process, and you can connect the controls database and to the simulator, and you can do like a factory acceptance test. And will this control logic work on the startup sequence for this plant? And by being able using the dynamic model to be able to do that, you can actually eliminate significant number of challenges. Before you actually go to live commissioning, which will ultimately shorten the commissioning time. There was a presentation at Aviva World Digital back in September by a gentleman from Shell who, they talked about using their simulation model to test the Emerson controls on a new ethylene cracker and polymer plant. And they were actually able to find as many issues. I think it was something like 500 issues were identified when they actually tested the control logic on their dynamic model for that facility across the 4 different pillars. So that is absolutely one application, but also engineering studies. Any revamp work, the model can be used to validate that the revamp is designed properly. So, there's a lot of payback to be realized from making an investment in building an OTS or an ITS.
I think in the control system design world that I came from, when you first building a new greenfield site, somebody has to figure out, what are you going to alarm? Where's the high temperature alarm? Where's the low pressure alarm, et cetera, et cetera. And there's a tendency there's a very common problem that when actually things go bad in real situations, you get alarm overload. The operators just, they throw their hands up. They don't even look at the current alarm summary. They just try to figure out the situational awareness because it was alarm overload. So, when you do a training simulator, would you not find some of these problems from alarm overload?
Yeah, absolutely. That's another great example. Yeah.
May I?
Yeah.
Rick, in terms of use of OTS for people other than panel officers, we've given it a lot of thought. And there is an angle where engineers and field operators can benefit from OTS throughout the year, not just during commissioning or just to set the control system straight, but by linking with scenarios, the OTS can be used by engineers to answer questions on what ifs. If either you get a situation and you solve it, or a situation, you look at a situation and reason why it happened. So there is a system that I ran into, which is not fully developed, called Tutor. At one time, Honeywell was playing with it. And our intention was to eventually develop it with help from the Aviva and integrate it with the OTS ITS system.
Wow, great. Any other last comments before we close the session? I think I'd like to thank everybody for coming to the ARC forum. I hope you had a chance to look around and see some of the other sessions and join some of the other chat rooms. There's been a lot of very interesting presentations on the OPA Foundation. Also, I was very interested to listen to some of the cybersecurity and some of the big problems that this solar winds intrusion, has caused, and the amount of trouble that might have still left behind very deep into an awful lot of computer systems. So clearly, the cybersecurity function that ARC focuses on has gotten worse, if not better. Also, there's been a lot of comments about remote operation and the impact of COVID-19 on everything. I just got a call earlier this morning that my 91-year-old mom and 92-year-old dad are going to get a vaccine here today or tomorrow. So they got on the list. We're trying to keep them alive. So, in any event, you guys did a great job. Really appreciate it. Matt, Brent, Ian, hopefully we'll stay in touch. Fantastic technology. An awful lot of operators are better off and plants are safer because of the work you guys have done.
Yep. Pleasure. Thank you for inviting us.
Thanks. Great job, Rick.
Yep. Bye.
Take care, everybody. Thanks for attending the forum.
Thank you. Bye-bye.